So welcome students. So in this question you're given that in the hyperbola x square by a square minus y square by b square is equal to 1. So if you draw a tangent at a point P whose eccentric angle is pi by 6, it makes an area of 3a square with the coordinate axis. If that is so, what is the value of e square? So let us analyze this question. So you have a hyperbola x square by a square minus y square by b square is equal to 1. You have a point P whose eccentric angle is pi by 6. That means the coordinates of point P are a secant pi by 6 and b tan pi by 6. So now what is the tangent at this point? What is the equation of tangent at this point? So the tangent at this point is x into a secant pi by 6 by a square minus y times b tan pi by 6 by b square is equal to 1. So 1a and a will get cancelled. So this is nothing but t is equal to 0. So x by a into secant pi by 6 is 2 by root 3. So 2 by a root 3 minus y by b into tan pi by 6. Tan 30 degrees is 1 by root 3. This b root 3 is equal to 1. Now what are the x-intercepts and what is the x-intercept of this and what is the y-intercept of this? So to find the x-intercept, put y is equal to 0. So if you put y is equal to 0, x-intercept is a root 3 by 2. And what is the y-intercept? So y-intercept comes if you put x is equal to 0. So if you put x is equal to 0, y-intercept is minus b root 3. Now what is the area of this triangle? So let the x-intercept be a and the y-intercept be b. So area is nothing but half times mod of x-intercept into y-intercept, that is a root 3 by 2 into b root 3, that is equal to, so 3ab by 4, 3ab by 4. So this is the actual area which is formed for this triangle, but this is given as 3a square. According to the given question, this is equal to 3a square. So 3 and 3 gets cancelled, a and a gets cancelled. This implies b by a is equal to 4 units. So b by a is equal to 4 units. Now what is the eccentricity of this hyperbola? E square is equal to 1 plus b square by a square, that is equal to 1 plus b by a whole square, that is 4 square is 16, that is equal to 17. It means the eccentricity of this hyperbola is 17 units. So now in the second part of the question, so given a hyperbola x square minus y square secant square theta is equal to 5 and an ellipse x square secant square theta plus y square is equal to 25. And the eccentricity of the hyperbola is root 3 times the eccentricity of the ellipse, that's given. So if that is so, what is the smallest possible value of theta? That is the question. Now let us try to write the mathematical equation corresponding to this information. So what is the eccentricity of the hyperbola? So eccentricity whole square is equal to 1 plus b square by a square. So y square secant square theta, if secant square theta comes down, it becomes cos square theta. So 1 plus cos square theta by x square coefficient is 1, so by 1, that is equal to 1 plus cos square theta. Now what is the eccentricity square of the ellipse? So E2 square is equal to 1 minus b square by a square, 1 minus b square by a square. So if you convert this into standard form, so x square by cos square theta plus y square by 1 is equal to 25. So if you bring this 25 down, it will be uniformly multiplied for both a square and b square. Now as you can see, this is not a horizontal ellipse, this is a vertical ellipse because cos square theta is less than 1. So the number below y is large, the number below x is small. So this will be b square and this will be a square. This will be the minor axis, semi-minor x square, and this will be the major x square. So 1 minus b square by a square becomes cos square theta by 1. That is equal to 1 minus cos square theta. So this is E1 square, this is E2 square. Now according to the given information, E1 square is equal to 3 times E2 square. This implies 1 plus cos square theta is equal to 3 minus 3 cos square theta. So 4 cos square theta is equal to 2. So cos square theta is equal to 1 by 2. So cos theta is equal to 1 by root 2. So theta is equal to pi by 4. So you have a general solution for theta. You have a lot of values of theta, but pi by 4 is the minimum value of theta. Pi by 4 is the smallest value of theta. So now if theta is equal to pi by 4, according to the given question, so theta is equal to 6 pi by p. So if you equate these two, you get pi and pi gets cancelled. So p is equal to 6 into 4 is 24. So the value of p is 24. So now let's go to the third part of the question. So in this question, you're given a hyperbola x square by 3 minus y square is equal to 3. And the angle between the asymptotes is given as L pi by 24. You're asked to find the value of L. So how do you get this? So what are the asymptotes of this hyperbola? The asymptotes of this hyperbola is x square by 3 minus y square is equal to 0. That means y is equal to plus or minus, x square. So y is equal to plus or minus x by root 3. These are the two asymptotes. So y is equal to x by root 3 and y is equal to minus x by root 3 are the asymptotes. So if you have x square minus y square is equal to some constant, if you take the constant as 0, that will be the asymptotes of the hyperbola. So you have two equations. So as you can see, one of them have slope 1 by root 3, the other have slope 1 minus 1 by root 3. So that means one of them make an angle of 30 degrees in the positive direction of x-axis, the other makes an angle of 30 degrees in the negative direction. So the angle between the asymptotes is 60 degrees, that is pi by 3. But this is given as L pi by 24. So pi and pi gets cancelled. So L is equal to 24 by 3, which is equal to 8. So the value of L in this case has to be equal to 8. So if you take the angle between the asymptotes as 60 degrees, you get L is equal to 8. But as you can see, if you take any two lines, there will be two angles between them. One is 60 degrees. So this angle, this is also the angle between the asymptotes. This angle is 120 degrees. So L pi by 24 can also be equal to 2 pi by 3. So if you equate L pi by 24 as 2 pi by 3, so L will be equal to 60. So the value of L can be either 16 or 8. So now let us go to the fourth question. So in the fourth part of the question, you're given a hyperbola xy is equal to 8 and you're asked to find the area of triangle formed by any tangent with the coordinate axis. So we know that xy is equal to 8 is a rectangular hyperbola. So if you take xy is equal to c square as a rectangular hyperbola, so the point on this curve can be represented by a parametric point which looks like ct comma c by t. So this is a parametric point on this hyperbola. Now at this parametric point, at this point, if you draw a tangent, the equation of this tangent can be written as x by t plus yt is equal to 2c. So this comes from the theory of xy is equal to c square. In the final part of the hyperbola, you have a theory of xy is equal to c square. This is a general equation of tangent to that at a point P whose parameter is t. Now if you want to find the area of this triangle, you just need to do half into x intercept into y intercept. So what is the x intercept? X intercept comes by putting y is equal to 0, that's equal to 2ct. So what is the y intercept? Y intercept comes by putting x is equal to 0, that is 2c by t. 2c by t. So what is the area of this triangle? Area of this triangle is equal to half times x intercept is 2ct into y intercept is 2c by t. So 2 and 2 gets cancelled, t and t gets cancelled, that is equal to 2c square. So area of the triangle formed by tangent at any point is independent of t because t got cancelled. So the area will always be a constant which is equal to 2c square. So according to this question, my c square is equal to 8 because xy is equal to whatever number is there, that is c square. So c square is equal to 8. So 2c square is equal to 16 units. So the area of the triangle will be 16 square units. Thank you.